Okay, so today's lesson, it's got two parts to it. This first little part is just us wrapping up what we did this past week. And we're just adding kind of another level to proofs, which I know for you might seem scary, but this is actually pretty simple. So if you want to put these in two separate pages of notes, you can definitely do that. So last week we talked about two things already. Congruent figures means we have congruent parts, and what we mean by that is corresponding parts are congruent. And you all learned when you did your IXL that it did make a difference in the order that you stated things because it listed things correspondingly. So for example, this statement, this triangle congruent statement, could tell us that angle A would be congruent to angle D, right? Because they're in corresponding spots. I could also say angle B is congruent to angle E, or angle C is congruent to angle F. It also tells us that sides or segments are going to be congruent. So for example, I could say that AC, side AC, is going to be congruent to, in the corresponding order, DE. Okay, so that was like the first thing we learned when we learned about congruent figures. And then we learned at the beginning of last week that triangles, there are some theorems we can use to prove that triangles are congruent. And specifically, there are 5 of those. So if you want to pause the video, see if you can remember all 5. All right, you should be getting side, 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 angle, side, angle, side, angle, 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 side, and then our one exception to side, side, angle, which is HL. Okay, and we talked about how to prove those. Remember, we would list all the given information, find any additional information, and then we would kind of treat these like a checklist, right? We would have to list all of them, check them off before we could make our final prove statement. So what we're going to do today is kind of combine these two things. So we're going to start our proofs obviously with our given information. Then we're going to treat our little checklist so that we can say that the triangles are congruent. And then because the triangles are congruent, so think about our checklist, right? Like our checklist for side, side, side means we say 3 sides are congruent. But if we know the sides are congruent, then we know the angles must be also. So our final statement will be to prove that corresponding parts are congruent, which, by the way, is what this CPCTC stands for. CPCTC stands for corresponding parts of congruent triangles are congruent. So you should probably have that written down, but to abbreviate, that's what we're going to say. All right, so let's look at one proof together. Okay, so here's the example we're going to do together. The given information has already been marked on the triangle, and just like we did last week, we want to go ahead and mark any other additional information. So from here, we should be able to mark vertical angles here in the middle. And then notice these have parallel lines, so that means I can trace and either look for corresponding lines or for a transversal, not for a transversal, for alternate interior. So if I trace there, I've traced my 2 parallel lines and my transversal, which is the line that both triangles share. And then I can find here that this is an example of something that has alternate interior angles. And if you kind of trace the Z, you should see that we've got these angles right here. Okay, so all of this is stuff that we did last week. And at the moment, if I look at this, that gives me this reason angle, angle, side. Now I want you to notice that the prove statement is different than it was this past week. So this past week, we were trying to prove the triangles are congruent. Now we're trying to prove that segments are congruent. So we're going to start our proof off like normal, and then I'm going to show you kind of what's different. So what I would like for you to do is pause the video and see if you can write this proof on your own, and then we'll compare notes. All right, so I got this far, and remember I'm using my angle, angle, side as kind of a checklist. So in statement 2 here, I've said that 2 sides are congruent, so I've said my sides. In statement 3, I name that there's a pair of angles congruent. And in statement 4, I do the same thing. Make sure that we have the right reasons. So now that my checklist is complete, I can go ahead and say that the triangles are congruent. So I'm going to say triangle TSU is congruent to triangle, and we want to keep corresponding orders. So that's going to be WVU. And the reason there was angle, angle, side. And now, just like you have in your notes from the first slide, our goal is to use the given information, then prove that the triangles are congruent. And my last step is going to be to prove that corresponding parts are congruent. So now, because I know the triangles are congruent, I technically know, and I could mark on here if I wanted to, that all of these other corresponding sides are congruent to one another, and all of the corresponding angles are congruent to one another. So they want me to say that TS is congruent to VW, and my reason there is going to be CPCTC, or that corresponding parts of congruent triangles are congruent. So really this looks a lot like what it did last week. It's just that we're going to have an additional step. Normally after we've said the triangles are congruent, we're going to add an additional step to say any of those corresponding parts are congruent. All right, so here's the second part of our lesson 7.1. We're going to be talking about interior and exterior angles of triangles and polygons. So we'll talk about what that means, but for the most part, we're going to focus in this video on triangles. So interior and exterior mean exactly what you think they do. Interior are going to be angles on the inside. So they've given us kind of an angle that's or a triangle as an example here. And our interior angles, like I just said, are going to be these angles on the inside. And you may even be asking, well, where are their exterior angles? I don't see any. Exterior angles will be like when we extend a side, we're talking about this whole outside angle. All right, that's what an exterior angle is. So let's talk about some relationships. Some of you may already know some things about the interior angles of a triangle. But I just want to tell you some things for sure so that you can solve some problems really throughout all the rest of geometry. Okay, so what I'm going to ask is that you stick with me because instead of just telling you the rule, I want to show you why it works. So what I'm going to start by doing, everything we learned about, not last week, but the week before, we talked about parallel lines. So I'm going to draw a line that's parallel to this bottom line up here at the top. Okay, these two lines are going to be parallel. Now, everything we talked about this past week when we talked about proofs, we said with parallel lines, we can usually find some special angle relationships. Okay, so I'm going to draw a transversal using the side of one of these triangles. And when I do that, I notice myself that there's an angle down here. We can call it angle 1 if we want to, this red angle, that's alternately interior to this angle up here at the top. All right, which means those two are going to be congruent. Okay, and then if I use this other transversal, so this side on the left, and I draw a transversal on this side, I can see another pair of alternate interior angles. So I've got this bottom angle down here in the corner. We can call it angle 2, and it's alternate interior, which means it's going to be congruent to this other angle. So hopefully you agree that those are alternate interior angles. Well, now notice this third angle obviously doesn't have like a pair on the transversal, but I can kind of color that in and call it angle 3. And if you notice, when you put those three angles together, look at what's happening with all three of those angles when they push up next to each other. And I hope that you see that all three of those angles together are making, well, I guess it's not a linear pair because there's three of them, but they are coming together to create a line, which means that all three of these angles are going to add, to equal 180. So that's our first theorem for today, is that all three angles of a triangle add to equal 180 degrees. All right, so you need to have that written down. There's another example that they do by like drawing, taking a triangle and cutting it out and tearing the edges. And even if you do that, and you can try that on your own if you just want to verify, no matter what triangle you draw, if you line up all the vertices down here in the corner, they are all going to make together 180 degrees. So it's always true of any triangle. Okay, so now I told you exterior angles are the angles on the outside of the triangle, which usually either there will be a line extended or you may have to draw a line extended to determine what an exterior angle is as far as its measure. So there are some relationships for exterior angles. You can draw this little image up here in the top corner. I'll zoom in for you and label what an exterior angle and remote interior angles mean. Remote interior, so if you think about if you're like in a remote part of the country or part of the city, you're like on the outskirts. So remote, we're talking about these two angles that are furthest away. They're on the inside of the triangle, but they're furthest away from this exterior angle. So not the one that it makes a linear pair with, but these other two angles in the triangle. And there's actually some special relationships that exist between all of these angles. So if we look at this example down here where they have the angles numbered, there's a few things that I know. The first thing that I know is that from a long time ago is that the measure of angle 3 plus the measure of angle 4 is going to equal 180 degrees. And the reason there is because these are a linear pair, so we know they're supplementary, so they add to equal 180. I think all of you are okay with that. And what we just learned is that all of these interior angles in the triangle also add to equal 180 degrees. So I could say the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3, again, is going to equal 180 degrees. So what I want you to see is that, right, the 180 is the same, and the measure of angle 3 is the same, which means the measure of angle 4 on its own must be the same size as the measure of angle 1 and 2. Otherwise, mathematically, that doesn't make any sense, right? These equations wouldn't work. So what the remote exterior angle theorem says, so you want to title that, remote exterior angle theorem, says that the sum of the two interior angles, so the measures of angle 1 plus the measures of angle 2, are equal, must be equal, to the measure of angle 4. And sometimes this is going to help us kind of shortcut some problems instead of having to do quite so much work on them, specifically when there's some algebra involved. So tomorrow we're going to work together to solve some of these problems, and we have one more theorem that we're going to talk about tomorrow, but you have to draw a lot of shapes, so I'm going to wait until I can give you a handout on that. All right, so make sure you got your notes ready, and we will talk on Monday.